A solar eclipse is a fascinating astronomical event that occurs when the moon passes directly between the Earth and the Sun, casting a shadow on the Earth and partially or completely blocking our view of the Sun. This phenomenon can only happen during a new moon, which is when the moon is positioned in such a way that it aligns with the Earth and the Sun. The process begins with the moon's orbit around the Earth, which takes about 27.3 days to complete. But because the Earth is also moving around the Sun, the alignment must be precise for an eclipse to happen. There are different types of solar eclipses, including total, partial, and annular eclipses. A total solar eclipse occurs when the moon completely covers the Sun, allowing observers in the path of totality to experience a dramatic darkening of the sky and even a drop in temperature during the day. This totality can last from just a few seconds to several minutes, depending on the specific circumstances of the alignment. On the other hand, a partial solar eclipse happens when only a portion of the Sun is obscured by the moon, which means that those positioned outside the path of totality can still see a part of the Sun shining around the edges of the moon. An annular solar eclipse is another unique type, occurring when the moon is too far from the Earth to completely cover the Sun, resulting in a ring of fire appearance, where the bright edges of the Sun are visible around the moon. The shadow cast by the moon during a solar eclipse consists of two main parts, the umbra and the penumbra. The umbra is the central, darkest part of the shadow, where a total eclipse can be seen, while the penumbra is the lighter outer part of the shadow, where a partial eclipse can be observed. As the moon moves across the Sun, observers in different locations will experience varying degrees of obscuration, depending on their position relative to the path of the eclipse. Throughout history, solar eclipses have captivated the attention of humans, inspiring awe and wonder, as well as fear, often being interpreted as omens or significant events. In modern times, they are closely studied by scientists, providing valuable opportunities to research the Sun's corona, the outer atmosphere that is usually hidden by the brightness of the Sun itself. The next solar eclipse can often be tracked well in advance, thanks to advances in astronomy and technology, allowing people to prepare for the event. Gather, a lunar eclipse occurs when the Earth comes between the Sun and the Moon, causing and create a stunning visual spectacle in the night sky. There are three distinct types of lunar eclipses, each with unique characteristics. The first type is a total lunar eclipse, which happens when the entire moon passes through the Earth's umbra, the darkest part of its shadow. During a total lunar eclipse, the moon often takes on a reddish hue, a phenomenon known as a blood moon, caused by sunlight scattering through the Earth's atmosphere while it filters out blue light. This creates a striking contrast, making the moon appear deep red or coppery, which can be mesmerizing for those watching. The second type is a partial lunar eclipse, which occurs when only a part of the moon enters the Earth's umbra, while the rest remains illuminated by direct sunlight. In this case, you can see a shadow creeping across the surface of the moon, creating a dramatic visual effect. As this shadow slowly moves and the illuminated portion gradually changes. Many people find partial eclipses fascinating, as they provide a clear demonstration of the Earth's shadow on the moon without the complete darkness of a total eclipse. The third type is a penumbral lunar eclipse, which is more subtle and often goes unnoticed by casual observers. During a penumbral eclipse, the moon may appear slightly shaded or have a duller color, but the change is so gradual and subtle that it can be difficult to detect without careful observation. Penumbral eclipses are often less dramatic than total or partial eclipses, but they still provide an interesting opportunity to observe the moon's changing appearance a few times a year, providing multiple chances for sky watchers to witness this celestial event. Each type of lunar eclipse has its own charm, and they remind us of the intricate dance between the Earth, the Sun, and the Moon, showcasing the beauty of our solar system and the wonders of astronomical phenomena. When it comes to solar eclipses, there are three main types that capture the wonder of skywatchers around the world: total, partial, and annular eclipses, each offering a unique experience as the moon travels between the Earth and the sun. A total solar eclipse occurs when the moon completely covers the sun, casting a shadow on Earth, creating a dramatic transformation in the sky, where day turns into night for a few minutes. As the sun's corona, which is the outer atmosphere of the sun, becomes visible, creating a breathtaking spectacle, this type of eclipse can only be seen from a specific path on Earth, known as the path of totality, where observers are able to witness the complete obscuration of the sun, while those outside this path will see a partial eclipse instead, where only a portion of the sun is hidden, leaving a crescent shape visible. On the other hand, a partial solar eclipse occurs when only part of the sun is obscured by the moon, which can be viewed from a much larger area compared to a total eclipse, allowing many more people to experience this phenomenon, although the transformation in light is not as dramatic as during a total eclipse. It's important to note that during a partial eclipse, the sun is never completely covered, and looking at the sun without proper eye protection can be dangerous, as it can cause serious eye damage. Then there is the annular solar eclipse. It happens when the moon is directly in front of the sun, but it is at a point in its orbit where it is too far away from Earth to completely cover the sun, resulting in a ring of fire effect, where a bright ring of the sun remains visible around the moon. This type of eclipse is particularly striking, as the contrast between the dark silhouette of the moon and the bright edges of the sun creates a stunning ring in the sky. Observers within the path of annularity, where this ring effect can be seen, experience a unique spectacle, while those outside of this path will see a partial eclipse, just like with the total eclipse. So, while total eclipses create a dramatic and complete covering of the sun, partial eclipses allow for a glimpse of the sun. Beautiful ring. Each type of eclipse delivers a different experience for those lucky enough to witness them, highlighting the marvels of our celestial mechanics and the intricate dance of the sun, moon, and Earth. Solar eclipses occur with a surprising frequency, yet they are not visible from every location on Earth every time they happen. On average, there are about 2 to 5 solar eclipses each year, but the specific type of eclipse, whether total, partial, or annular, can vary. A total solar eclipse, where the moon completely covers the sun, is an awe-inspiring event, and it happens roughly once every 18 months somewhere on Earth, though any single location might only experience it once every 375 years or so. The reason for this rarity at specific sites is due to the narrow path of totality, which is the area where observers can see the total eclipse. This path can be just over 100 miles wide, meaning that many places on Earth will miss out entirely on witnessing this spectacular phenomenon in any given occurrence. Moreover, the cycles of solar eclipses follow a pattern known as the Saros cycle, which lasts about 18 years, 11 days, and 8 hours, leading to a series of eclipses that share similar geometry. This means that after one eclipse, you can often predict where the next similar eclipse will be visible, although it still won't be in the same place. Eclipses also tend to cluster, with several occurring in a relatively short time frame, followed by long periods without any. This creates opportunities for enthusiasts to plan trips to witness these events, as certain locations, such as parts of the United States, South America, and Asia, are favored for eclipse viewing due to their geography. Understanding these patterns not only deepens our appreciation for celestial mechanics, but also enhances our experiences as we await the next spectacular dance of the sun and moon. Supermoon is a fascinating astronomical phenomenon that occurs when the full moon coincides with its closest approach to Earth in its elliptical orbit, a point known as perigee. This combination makes the moon appear larger and brighter in the sky compared to a regular full moon, which happens when the moon is at apogee, or its farthest point from Earth. To put it simply, during a supermoon, the moon can appear up to 14% larger and 30% brighter than when it is at its farthest distance. This striking visual effect is not just a matter of perception. The difference is noticeable to the naked eye, and many people enjoy taking photos or simply gazing at the breathtaking sight in the night sky. Popularized in 1979 by an astrologer, though astronomers have since adopted it, recognizing that this event can occur several times a year. The supermoon occurs when the moon is full, but not every full moon is a supermoon. It must be at or near perigee to qualify. The gravitational pull of the moon also contributes to the tides on Earth, and during a supermoon, the tides can be slightly more extreme, leading to what is known as king tides. These higher tides can affect coastal regions, sometimes leading to flooding or changes in the shoreline, which is an important consideration for those living near the ocean. Interestingly, the moon's phases, including supermoons, are a result of the relative positions of the Earth, the moon, and the sun. When the sun, Earth, and moon align perfectly, we experience a full moon. But when this alignment occurs at perigee, we enjoy the spectacle of a supermoon. It's a reminder of the dynamic nature of our solar system and how celestial bodies interact with each other. The next time you catch sight of a supermoon, take a moment to appreciate the intricate dance of these astronomical giants as they continue to captivate our imaginations and inspire wonder across cultures and generations. A blue moon is a fascinating phenomenon, often shrouded in a bit of mystery and misunderstanding. The term blue moon actually has two definitions, the first being the more traditional one, which refers to the second full moon that occurs within a single calendar month. This happens because the lunar cycle, which lasts about 29.5 days, can sometimes result in two full moons in 1 month, typically when the first full moon occurs at the very beginning of the month. This is relatively rare, happening approximately once every 2 to 3 years, but it isn't as uncommon as many people think. The second definition of a blue moon, which is less commonly used today, refers to the third full moon in a season that has 4 full moons, rather than the usual 3. This definition comes from an old Maine farmer's almanac and is rooted in tradition. But in terms of how often blue moons occur, if we consider the first definition, we can expect to see one about every 2.7 years. But this can vary, of course, depending on the specific timing of the lunar phases. The last blue moon happened on August 31, 2023, and the next one is expected to occur in 2026. The sight of a blue moon can be quite enchanting, especially since the name might lead one to expect a blue-hued moon, which is not the case. The moon does not actually appear blue. The name is simply a quirky aspect of language and culture. However, the moon can appear blue under certain atmospheric conditions, such as after a volcanic eruption or during a significant forest fire, when particles in the air scatter light differently. These events are rare, but they give a striking visual effect of a blue-hued moon. So, while the blue moon itself doesn't change color, its occurrence is a delightful reminder of the complexities of our lunar calendar, and it captivates the imagination of those who take the time to look up at the night sky. A meteor shower, often referred to as a meteor stream, is a celestial event during which numerous meteors are observed to radiate from a specific point in the night sky, typically when the Earth passes through the debris left behind by a comet, or, in some cases, an asteroid. These meteors, also known as shooting stars, are actually small particles, often no larger than a grain of sand, that enter the Earth's atmosphere at high speeds, usually around 2,5,0,000 miles per hour, causing them to burn up and create a bright streak of light as they disintegrate due to the intense heat generated by friction with the atmosphere. Meteor showers can occur at any time of the year, but certain showers are more prominent and predictable, such as the Perseids, which peak in August, and the Geminids, which reach their maximum in December. To observe a meteor shower, it's best to find a location away from city lights, as light pollution can obscure the view of the night sky and make it difficult to see the meteors. A dark, open area such as a park or a rural site is ideal for viewing because it allows for a wider perspective of the sky. Observers should lay back on a blanket or reclining chair, allowing their eyes to adapt to the darkness for about 20 to 30 minutes, which enhances the ability to see more meteors. It's also helpful to know the peak dates of the meteor shower, as well as the constellation from which the meteors appear to radiate, known as the radiant point. For example, during the Perseids, the radiant is in the constellation Perseus, blue 1,000 miles longer. The best time to watch is usually after midnight, reaching its peak activity just before dawn, as this is when the Earth is turning into the oncoming stream of meteoroids, increasing the chances of seeing more meteors. While observing, it's important to keep an eye on the entire sky rather than just focusing on the radiant point, since meteors can appear in any part of the sky. Some people even like to bring along a camera to capture the event, though this can be tricky as meteors appear and disappear very quickly. Taking long exposure photographs can sometimes yield amazing results if the camera is set up correctly. In addition, meteor showers can be accompanied by various atmospheric phenomena such as bright fireballs or even bolides, which are particularly bright meteors that can be seen over a wide area and often polar. The Perseids meteor shower, which occurs every August, holds significant importance not only for its stunning visual display, but this annual event, stemming from the debris left behind by the Swift-Tuttle comet, captivates skywatchers around the world, as it produces a remarkable number of meteors, often peaking at over 60 meteors per hour during its height. The Perseids are particularly noteworthy because they provide an opportunity for people of all ages to witness a natural spectacle that has been observed for centuries. Ancient cultures, such as the Greeks and Romans, regarded meteor showers as omens or messages from the gods, which adds a layer of cultural significance to the event. In modern times, the Perseids have become a focal point for astronomers and amateur stargazers alike, who gather in open areas away from city lights to enjoy this celestial display. The meteor shower is significant for scientific reasons too, as it enables astronomers to study the composition of the comet's debris, offering insights into the early solar system and the materials that formed the planets. Additionally, the Perseids are a reminder of the dynamic nature of our solar system, showcasing how cosmic events can influence life on Earth. The peak of the Perseids often coincides with warm summer nights, making it a perfect occasion for families and friends to gather, share stories, and enjoy the beauty of the night sky. Many traditions have emerged around this event, from making wishes on shooting stars to participating in community stargazing events, fostering a sense of connection among people as they all look up in wonder together. This meteor shower also serves as an important educational tool, as schools and organizations often use it as an opportunity to engage students and the public in discussions about astronomy, physics, and environmental science. The visibility of the Perseids combined with their historical significance encourages curiosity and exploration of the cosmos, inspiring future generations of scientists and enthusiasts. Moreover, the Perseids can also have an impact on local ecologies, as the bright streaks of light illuminate the night sky, attracting the attention of not just humans but also various wildlife, which may respond to these cosmic displays in unique ways. This interconnectedness between celestial events and earthly life emphasizes the significance of the Perseids beyond mere visuals, highlighting how astronomical phenomena can influence both natural and cultural landscapes. The Perseids meteor shower with its blend of beauty, science, and cultural history. Comets and asteroids, while both classified as small bodies in our solar system, have distinct characteristics that set them apart. Comets are often described as dirty snowballs, primarily because they are composed of ice, dust, and rocky material, which gives them their unique appearance. While asteroids, on the other hand, are mostly made of rock and metal, and they resemble miniature planets, lacking the icy components that comets have. When comets approach the sun, the heat causes the ice to vaporize, creating a glowing coma, and sometimes a spectacular tail that can stretch millions of kilometers. This tail always points away from the sun due to solar wind, making comets visually striking during their journey through the inner solar system. In contrast, asteroids do not develop tails or comas, as they do not possess significant amounts of volatile materials. Instead, they remain relatively unchanged as they orbit the sun, which can make them less visually exciting during astronomical events. Moreover, the orbits of comets and asteroids differ significantly, as comets typically have highly elliptical orbits that take them far into the outer solar system before they swing back towards the sun, sometimes taking hundreds or thousands of years to complete one orbit. In fact, famous comets, like Halley's Comet, are known for their periodic appearances. Asteroids, in contrast, tend to have more circular orbits, often found in the asteroid belt between Mars and Jupiter, and they usually exhibit less dramatic changes in brightness and visibility during their orbits. This difference in their trajectories contributes to how these celestial bodies are perceived during astronomical events, with comets often being associated with awe and wonder, while asteroids are sometimes viewed as more mundane, although they also play crucial roles in our understanding of the solar system. Additionally, the composition of comets and asteroids leads to different outcomes during potential impacts with comets. When they enter the Earth's atmosphere, can create brilliant meteoric displays known as meteor showers, especially if they break apart, releasing particles that burn up upon entry. These events can be quite spectacular, filling the night sky with streaks of light. Asteroids, however, can pose a more significant threat, as their solid rocky structure can survive the journey through the atmosphere and reach the Earth's surface, potentially causing considerable damage depending on their size. The study of both comets and asteroids is vital for astronomy. A transit of Venus occurs when the planet Venus passes directly between the Earth and the Sun, appearing as a small black dot moving across the Sun's bright face. This event is quite rare, happening in pairs 8 years apart, followed by a long gap of over a century before the next pair appears. The most recent transits occurred in 2004 and 2012, but the next won't take place until 2117, which adds to the intrigue and historical significance of these occurrences. The transit of Venus has been observed for centuries, and it played a crucial role in the development of astronomy and our understanding of the solar system. Historically, the first recorded transit took place in 1639, observed by British astronomer Jeremiah Horrocks, who calculated the transit's timing. This observation allowed astronomers to refine their measurements of the distance from the Earth to the Sun, a critical factor in understanding the scale of our solar system. The transit of Venus was also significant in the context of the 18th century, when astronomers from around the world traveled to different locations to observe the event, as it provided a unique opportunity to gather data about the solar system's dimensions. One of the most notable expeditions occurred in 1761 and 1769, when astronomers journeyed to places as far as Siberia, Tahiti, and the southern tip of Africa, all to record the transit in hopes of calculating the astronomical unit, which is the average distance from the Earth to the Sun. This quest not only advanced scientific knowledge, but also fostered international collaboration among scientists of different countries showcasing the collective human effort to understand the cosmos. The transit of Venus has also entered popular culture, inspiring artists, poets, and writers who have a metaphor for love and longing, as the planet Venus is named after the Roman goddess of love, and its transit is a reminder of the delicate and transient nature of celestial events. The historical significance of the transit of Venus extends beyond just its scientific value. It symbolizes humanity's quest for knowledge and our deep connection to the universe, prompting us to explore, discover, and understand the mysteries that lie beyond our world. A blood moon occurs during a total lunar eclipse, when the Earth passes directly between the Sun and the Moon, casting a shadow over the Moon. This beautiful phenomenon gets its name from the reddish tint that the Moon takes on, which is caused by Rayleigh scattering, the same effect that causes sunsets to appear red. As sunlight passes through the Earth's atmosphere, it gets filtered, with the shorter blue wavelengths scattering out, while the longer red wavelengths bend around the Earth and illuminate the Moon. This gives the Moon its striking deep red or coppery hue, which can vary based on atmospheric conditions, such as pollution or volcanic ash in the air, that can enhance the color. The entire event can be quite dramatic, with the Moon gradually darkening and changing color as it moves through the Earth's shadow, typically taking about 3 hours from start to finish. Interestingly, during a total lunar eclipse, the Moon can become so dark that it is almost invisible, except for the light that is refracted through the atmosphere, creating that iconic blood-red appearance. Different cultures have viewed blood moons with a mix of wonder and superstition, often interpreting them as omens or signs, while astronomers see them as opportunities to study the Earth's atmosphere and its effects on light. The duration and intensity of the red appearance can vary significantly, depending on the location of the Moon in relation to the Earth and the Sun, as well as the specific atmospheric conditions at that time. Some people enjoy gathering to watch these eclipses, sharing the experience with friends or family, while others take the opportunity to photograph this rare celestial event, capturing the different shades of red and the Moon's transformation during the eclipse. The next time you witness a blood moon, remember that it is not just a beautiful sight, but also a reminder of the intricate dance of celestial bodies and the science behind these awe-inspiring cosmic events. Viewing a solar eclipse can be an awe-inspiring experience, but it's crucial to prioritize safety, as looking directly at the Sun, even during an eclipse, can cause serious eye damage. The safest way to observe a solar eclipse is by using special solar viewing glasses, which are designed to block harmful solar radiation, allowing you to look at the Sun without risking your vision. These glasses must meet the ISO 123122 International Safety Standard, ensuring they provide adequate protection. It's important to check for any scratches or damage before using them, as this could compromise their effectiveness. If you don't have solar viewing glasses, another safe method is to use a pinhole projector, which allows you to project an image of the Sun onto a surface, so you can see the eclipse indirectly. You can create a simple pinhole projector by making a small hole in a piece of cardboard, then holding it in the sunlight, allowing the sunlight to pass through the hole and create a small image of the eclipse on the ground or another flat surface. Additionally, you can use a colander or a strainer to project multiple images of the eclipse by holding it to the Sun, letting the light shine through the holes, which creates a pattern of images on the ground below. For those who have access to telescopes or binoculars, it's essential to use a solar filter specifically designed for those devices. Never look through telescopes or binoculars with regular sunglasses, as this does not provide adequate protection and can lead to severe eye injury. If you are interested in photography, specialized solar filters are available for cameras as well, allowing you to capture the event safely. It's also important to know that during a total solar eclipse, When the moon completely covers the sun, it is safe to remove your solar viewing glasses only during the brief period of totality. However, as soon as the sun begins to reappear, you must put the glasses back on, so remember to check your local eclipse times, as these can vary depending on your location, ensuring you don't miss the opportunity to witness this magnificent celestial event safely. Always prioritize your eye safety, as the sun's rays can be damaging, and enjoying the eclipse responsibly will make for a memorable experience. During an annular eclipse, the phenomenon known as the Ring of Fire occurs, and this happens when the moon passes between the Earth and the sun, but the moon is at a point in its orbit where it is too far away from the Earth to completely cover the sun. As a result, instead of a total eclipse, the moon obscures the central part of the sun, leaving a bright outer edge visible, which creates that stunning ring-like appearance. The Ring of Fire is most prominent at the peak of the annular eclipse, when the alignment is just right. The term annular itself comes from the Latin word for ring, which perfectly describes the visual effect. This phenomenon can only be seen from certain locations on Earth, where the alignment allows observers to see the ring. The path of the annular eclipse, known as the path of annularity, is typically quite narrow, which means that those outside this path will see a partial eclipse instead. During the event, the brightness of the sun is reduced significantly, but not completely blocked, leading to a unique experience where you can see the bright ring surrounding the dark silhouette of the moon. The ring can appear to shimmer and change in intensity, depending on atmospheric conditions, and this adds to the beauty of the event. It's also interesting to note that this Ring of Fire effect can only be experienced during specific times, as the orbits of the Earth and Moon change constantly. Because the Moon's orbit is elliptical, its distance from Earth varies, which is why sometimes it appears larger in the sky and at other times smaller. When it is smaller, it creates the annular eclipse. This rare cosmic event often attracts a lot of attention, with people traveling to the best viewing locations to witness the spectacle. It's recommended to use proper solar viewing glasses or filters to safely observe the eclipse, as looking directly at the sun, even during an annular eclipse, can cause serious eye damage. The excitement and anticipation that build up before the event can be palpable, with many astronomy enthusiasts preparing for months in advance. The Ring of Fire is not just a beautiful sight, it also offers scientists an opportunity to study the sun's corona, which is the outer atmosphere of the sun. During an annular eclipse, the corona can sometimes be seen more clearly than during a total eclipse, allowing researchers to gather valuable data about solar activity and its effects on space weather. The term supermoon has its origins rooted in the field of astronomy, specifically in the way that the moon's orbit interacts with Earth. The phrase was first popularized in 1979 by astrologer Richard Nolay, who defined it as a new or full moon occurring when the moon is within 90% of its closest approach to Earth, known as perigee. This definition captures the essence of what makes a supermoon special, as during this time, the moon appears larger and brighter in the sky than usual, creating a stunning visual spectacle for sky watchers and casual observers alike. Although Nolay coined the term, the phenomenon itself has been observed for centuries, with ancient cultures often attributing various meanings and significance to the moon's changing phases, including the increased brightness and size of. A supermoon can be attributed to the moon being about 14% closer to Earth than its average distance, which is around 238,855 miles or 3,84400 kilometers. This difference in distance can lead to a dramatic visual effect, often inspiring awe and wonder among those who take the time to look up at the night sky. Interestingly, the scientific community has been a bit cautious about the use of the term supermoon, as it is not an official astronomical term, but rather one that has gained popularity in media and among the public. Astronomers prefer to refer to the events in more technical terms, such as perigee syzygy, which describes the alignment of the Sun, Earth, and Moon during these occurrences. Regardless of the terminology, the supermoon phenomenon has captured the imagination of many, leading to significant media coverage and public interest whenever one is expected to occur. In recent years, supermoons have become a prime opportunity for photographers and amateur astronomers, as the enhanced brightness and size can create breathtaking images. Social media platforms are often flooded with pictures of the moon during these events, as people from all walks of life share their experiences and observations. The combination of science, art, and public interest makes supermoons a fascinating topic, showcasing how a natural celestial event can bring people together in appreciation of the universe we inhabit. As we continue to explore the wonders of our solar system, the supermoon serves as a reminder of the beauty and complexity of celestial mechanics, inviting us to look up and marvel at the night sky. While this intersection of science, solar flares, which are sudden bursts of energy from the sun's surface, can have a significant impact on Earth and its atmosphere, creating both stunning displays and potential hazards. When a solar flare occurs, it releases a vast amount of energy, including X-rays and ultraviolet radiation, which travel through space at the speed of light. When this radiation reaches Earth, it can interact with our atmosphere, particularly the ionosphere, which is a layer of charged particles high above the surface. This interaction can lead to disturbances in radio communications, especially in high-frequency bands, which are crucial for aviation and maritime operations. In some cases, these disruptions can cause blackouts in radio signals, affecting not just communications, but also navigation systems that rely on satellite signals. Moreover, solar flares can also influence the Earth's magnetic field. When charged particles from the Sun, known as solar wind, collide with the Earth's magnetosphere, they can cause fluctuations in the magnetic field, leading to beautiful auroras, commonly seen near the polar regions. These displays of light, known as the aurora borealis in the northern hemisphere and aurora australis in the southern hemisphere, are a direct result of the solar particles interacting with the gases in our atmosphere, creating vibrant colors that dance across the night sky. However, the effects of solar flares are not limited to just aesthetic displays. The increased radiation and energetic particles can pose a risk to satellites orbiting the Earth. Satellites can be damaged or even rendered inoperative due to the intense radiation, which can interfere with their electronic systems and sensors. Additionally, astronauts in space are at a heightened risk during solar flare events, as they are exposed to high levels of radiation, which can have harmful effects on their health. Furthermore, solar flares can also impact power grids on the ground. Geomagnetic storms induced by these flares can cause fluctuations in electrical currents, which may lead to transformer damage and power outages. In fact, a severe geomagnetic storm in 1989 caused a 9-hour blackout in Quebec, Canada, affecting millions of people. This demonstrates the potential real-world consequences of solar activity on our technology-independent society. Scientists constantly monitor solar activity to predict when solar flares might occur, utilizing various space-based observatories and ground-based instruments. By understanding the patterns and frequency of solar flares, we can better prepare for their effects, safeguarding our technology and infrastructure from potential disruptions. A study of solar flares. A triple conjunction of planets, where 3 planets align closely in the sky, is a fascinating astronomical event that captures the interest of sky watchers and astronomy enthusiasts alike. These alignments are relatively rare occurrences, often happening only once every few years, but the exact frequency can vary depending on which planets are involved in their respective orbits. The alignment usually involves planets that are relatively close to each other in the sky, which can create stunning visual displays for those fortunate enough to witness them. The rarity also stems from the fact that the orbits of the planets are tilted at different angles, and they move at different speeds, making it a unique event when they align closely enough to be considered a conjunction. For example, the last notable triple conjunction involved Jupiter, Saturn, and Venus, which occurred in the early 2020s. Such events can sometimes be anticipated, as astronomers can calculate the positions of planets years in advance, but the actual viewing can still depend on local weather conditions, light pollution, and the time of year. Historically, triple conjunctions have been significant in various cultures, often being interpreted as omens or signs. In modern times, they provide a wonderful opportunity for education and engagement with astronomy as people gather to observe and discuss these celestial events. The next opportunity to witness a triple conjunction will likely be a highly anticipated event, drawing the attention of both amateur astronomers and seasoned professionals who are eager to share their knowledge and excitement with others. A planetary alignment, which can also be referred to as a planetary conjunction, occurs when planets in our solar system appear to line up in the same region of the sky from our perspective on Earth. This fascinating phenomenon can take place in several ways. Sometimes it might involve just two planets, while at other times it could include several of them, creating a stunning celestial display. The alignment happens due to the planets orbiting the Sun at different distances and speeds, which means that they occasionally come into a straight line at least as seen from our viewpoint. Typically, these alignments are not as common as one might think because the planets are spread out over vast distances and have different orbital periods. For example, while Earth takes 1 year to orbit the Sun, Jupiter takes about 12 years, and Saturn requires nearly 30. This means that the timing of alignments can vary significantly, and they often don't happen at regular intervals. However, major alignments that involve several planets can be seen roughly every few decades, while smaller alignments might happen more frequently, perhaps every few years. When planets align, they can create visually stunning arrangements in the night sky, often drawing the attention of astronomers and sky watchers alike. These events can be exciting opportunities for both amateur and professional astronomers, as they offer a chance to observe the planets in relation to one another, and sometimes even to other celestial bodies, like stars or the moon. Moreover, planetary alignments can occur in different forms, such as conjunctions, where two or more planets come extremely close together in the sky, or a more extended alignment where several planets are spread out but still visible within a similar area. The next notable planetary alignment is expected to occur in the near future, bringing many enthusiasts out to gaze at the night sky, hoping to catch a glimpse of these magnificent cosmic arrangements. It's also interesting to note that while some people believe planetary alignments might have astrological significance or effects on human behavior, scientifically, there is little evidence to support such claims. The gravitational effects of the planets on Earth are minuscule, and any supposed influence on our lives remains in the realm of speculation. Nevertheless, for those who appreciate astronomy and the beauty of our universe, planetary alignments are a captivating subject, and they serve as a reminder of the intricate dance of celestial bodies that occur around us, creating a magnificent tapestry in the vastness of space. The equinoxes and solstices hold great significance in astronomy, as they mark key points in the Earth's annual journey around the Sun, influencing not only our understanding of celestial mechanics, but also our cultural practices and timekeeping. The equinoxes, occurring twice a year, signify the moments when day and night are of approximately equal length, which happens around March 21st and September 23rd. The March equinox, known as the vernal equinox, signals the onset of spring in the northern hemisphere, while the September equinox heralds the arrival of autumn. These events are crucial for astronomers because they help establish a reference point for measuring time and tracking the position of the sun in the sky. They also play an important role in the seasonal changes we observe on Earth, affecting everything from weather patterns to animal migrations and even agricultural practices. On the other hand, the solstices, which occur around June 21st and December 24th, represent the times of the year when the sun reaches its highest or lowest point in the sky at noon, resulting in the longest and shortest days respectively. The June solstice, known as the summer solstice in the northern hemisphere, marks the longest day of the year, while the December solstice, or winter solstice, denotes the shortest day. These points in time are significant not only for marking the seasons, but also for various cultural and religious celebrations throughout history. Many ancient civilizations, such as the Egyptians and the Mayans, built monuments aligned with the sun's position during these events, reflecting their importance in understanding the cosmos and their connection to agriculture. Help determine the Earth's axial tilt, which is about 23.5 degrees, a factor that influences climate and seasonal variation across different regions. In addition, astronomers utilize these events to refine their models of the solar system, as variations in the timing of equinoxes and solstices can provide insights into the gravitational influences of other celestial bodies. For instance, the precession of the equinoxes, a slow shift in the orientation of the Earth's rotational axis, occurs over a cycle of approximately 2,6,000 years and can affect the timing of these events over millennia. Understanding this precession is essential for astronomers studying ancient texts and calendars, allowing them to reconstruct past astronomical events and their significance to various cultures. As a result, equinoxes and solstices, not only a nova is an astronomical event characterized by a sudden, bright eruption of a star, which can increase its brightness by thousands of times, often becoming visible even to the naked eye. This phenomenon typically occurs in a binary star system, where one star is a white dwarf, a remnant from a star that has exhausted its nuclear fuel and collapsed, while the other star is typically a companion, often a main sequence star or a red giant. As the white dwarf pulls material from its companion, hydrogen accumulates on its surface, and when the pressure and temperature become high enough, nuclear fusion ignites, resulting in this brilliant explosion which can last for several weeks to months, after which the star returns to its previous state, becoming less luminous over time. On the other hand, a supernova is an entirely different and much more powerful event. It marks the explosive death of a star, which can occur in two primary ways, either through the core collapse of a massive star at least 8 times the mass of our Sun, when it exhausts its nuclear fuel, leading to a gravitational collapse, or through a runaway nuclear reaction in a white dwarf that has accumulated too much mass exceeding the Chandrasekhar limit, resulting in its catastrophic explosion. Supernovae can outshine entire galaxies for a brief period, releasing an incredible amount of energy, often producing heavy elements that are crucial for the formation of planets and life. So while both novas and supernovae involve explosions and brightness, the scale and causes of these events are significantly different, with novas being relatively gentle outbursts associated with binary systems, and supernova being cataclysmic events marking the end of a star's life cycle. Both phenomena are essential to our understanding of stellar evolution and the life cycles of stars, contributing to the cosmic landscape in their unique ways. Black holes, those mysterious regions in space where gravity is so strong that nothing, not even light, can escape, create observable astronomical events in several fascinating ways, and understanding this can be quite intriguing. One of the most significant phenomena associated with black holes is the concept of accretion disks. When a black hole pulls in matter, such as gas and dust, from a nearby star or surrounding space, this material doesn't just fall straight in. Instead, it spirals around the black hole, forming As this matter gathers and spins, it heats up due to friction and gravitational forces, emitting vast amounts of energy, particularly in the form of X-rays, which astronomers can detect with space telescopes, allowing us to observe black holes indirectly. Another remarkable event linked to black holes is the emission of jets. Some black holes, especially supermassive ones found at the centers of galaxies, can launch powerful jets of particles at nearly the speed of light. These jets are formed when not all the infalling material gets absorbed. Instead, it can be ejected along the rotational axis of the black hole, producing beams of radiation that can be observed over great distances. These jets can impact the surrounding galaxy, influencing star formation and the overall dynamics of the galactic environment, making them a key feature in understanding how black holes affect their surroundings. Additionally, black holes can create gravitational waves, ripples in space-time, when they merge with other black holes or neutron stars. This was first detected in 2015 by the LIGO Observatory, marking a groundbreaking moment in astrophysics. The merging process releases an enormous amount of energy, which can be detected by sensitive instruments on Earth, providing us with a new way to observe and understand the universe. Moreover, when stars get too close to a black hole, they can be torn apart in a process known as spaghettification due to the extreme difference in gravitational pull on different parts of the star. The debris from this event can also form an accretion disk and emit X-rays, providing another observable signature of black holes. Black holes also play a crucial role in the dynamics of galaxies. The presence of a supermassive black hole at a galaxy's center can influence the orbits of stars and gas within that galaxy. Observations of stars orbiting around an invisible mass at the center of our Milky Way, for instance, have provided strong evidence for the existence of a supermassive black hole, known gravitational waves, which were first predicted by Albert Einstein in 1916, are ripples in the fabric of space-time, created by some of the universe's most violent and energetic processes, such as merging black holes or neutron stars. When massive objects accelerate, they can disturb space-time, causing waves to propagate outward at the speed of light. These waves carry information about their origins and about the nature of gravity, making them a fascinating area of study in astrophysics. Detecting these elusive waves requires incredibly sensitive instruments, as the distortions they cause are extremely small, often just a fraction of the diameter of a proton, which make one of the most significant achievements in gravitational wave detection came with the Laser Interferometer Gravitational Wave Observatory, or LIGO, which uses a technique called laser interferometry. In this setup, two long arms, each several kilometers in length, are arranged in an L shape. A laser beam is split into two, with each beam traveling down one arm, reflecting off mirrors, and then returning to the original beam splitter. When a gravitational wave passes through, it stretches one arm while squeezing the other, causing a slight difference in the time it takes for the beams to return. This difference is measured with extreme precision, allowing scientists to detect the presence of a gravitational wave. LIGO made headlines in 2015 when it detected gravitational waves resulting from the merger of two black holes, marking the first direct observation of these phenomena and confirming a major prediction of Einstein's general theory of relativity. Since then, other observatories, like Virgo in Italy and Kagra in Japan, have joined the effort, increasing the sensitivity and accuracy of gravitational wave detection. With advancements in technology, scientists have been able to observe a variety of cosmic events, providing a new way to explore the universe. The field continues to grow, with new discoveries being made, and researchers are excited about the potential for future detections that could reveal even more about the fundamental workings of the cosmos. The collision of neutron stars, a rare and fascinating cosmic event, has captured the interest of astronomers and astrophysicists alike, as it holds significant implications for our understanding of the universe, particularly in the realms of gravitational waves, heavy element formation, and the behavior of matter under extreme conditions. When two neutron stars collide, they create a cataclysmic explosion known as a kilonova, which dramatically outshines typical supernovae, releasing an immense amount of energy. This energy is not just in the form of light, but also in gravitational waves. Ripples in spacetime that were first detected by LIGO in 2015, and which provided a new way to observe the cosmos. The detection of gravitational waves from a neutron star collision, specifically the event named GW1 70817 in 2017, marked a groundbreaking moment in astrophysics, confirming the existence of these waves and demonstrating their potential to inform us about the nature of space-time and the fundamental forces of the universe. Moreover, neutron star collisions are believed to be a primary site for the creation of heavy elements, such as gold and platinum, through a process called rapid neutron capture, or R process, nucleosynthesis. When the neutron stars merge, the extreme conditions generate a massive influx of neutrons, allowing elements to form quickly before they can decay. This means that many of the precious metals we find on Earth may have originated from such cosmic events, reshaping our understanding of the origins of these elements in the universe. Additionally, the study of these collisions provides insights into the behavior of matter at incredibly high densities, far beyond what can be replicated in laboratories on Earth. Researchers are keen to learn how matter behaves under these conditions, as neutron stars are some of the densest objects in the universe, with a mass greater than that of the Sun compressed into a sphere just a few kilometers wide. Furthermore, the implications extend into the realm of cosmology and the evolution of galaxies. The frequency and distribution of neutron star formations can help scientists understand the rates of star formation in galaxies, as well as the processes that lead to the creation of neutron stars themselves. These observations can reveal the life cycles of stars and the dynamics of stellar evolution, shaping our overall understanding of the universe's history. The energy released in a neutron star collision, combined with the subsequent dispersal of heavy elements, plays a vital role in the chemical evolution of galaxies, influencing the formation of new stars and planetary systems. In summary, when a total lunar eclipse occurs, it can have a fascinating effect on tides, which is primarily due to the gravitational pull of the moon. Excerpents, 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 excerpents. Normally, the moon exerts a significant gravitational force on Earth, causing ocean tides to rise and fall in a regular pattern. During a total lunar eclipse, the Earth, Moon, and Sun align, with the Earth positioned directly between the Sun and the Moon. This alignment does not alter the gravitational forces drastically, but during the eclipse, the Moon moves into the Earth's shadow, resulting in a temporary dimming of its light. And while this does not directly influence the gravitational pull, the position of the Moon does play a role in tidal variations. Tides generally follow a cyclical rhythm, with high tides occurring when the Moon is directly overhead or on the opposite side of the Earth, and low tides occurring when the Moon is at a right angle to a given location. However, during a total lunar eclipse, the Moon's position relative to Earth changes, leading to a more pronounced high tide known as a king tide. The phenomenon is particularly interesting because, during a total lunar eclipse, the gravitational forces from both the Moon and the Sun can create variations in tidal heights. The timing of these tides can also be affected by the eclipse's duration, which lasts several hours. As the moon passes through the Earth's shadow, observers may note that the high tides can become even higher than usual, while low tides may drop lower, creating a more dramatic contrast. Moreover, it's worth mentioning that this alignment can coincide with seasonal variations, such as spring tides, which occur when the Sun, Earth, and Moon are in alignment, amplifying the high tides even more. This combination of factors means that, during a total lunar eclipse, people living along coastlines might notice a more pronounced effect on the tides, particularly in regions where the tidal range is already significant. Although these changes are generally subtle and may not be felt by everyone, they highlight the interconnectedness of celestial events and natural phenomena here on Earth. It's a captivating reminder of how the movements of celestial bodies can have real, tangible effects on our planet. A solar maximum is a phase in the solar cycle, which is an approximately 11-year cycle that describes the fluctuation in the Sun's activity, including the number of sunspots, solar flares, and coronal mass ejections. During this phase, the number of sunspots on the Sun's surface significantly increases. Sunspots are temporary phenomena on the Sun's photosphere, appearing as spots that are darker than the surrounding areas due to their lower temperature. The solar maximum is characterized by a peak in the number of these sunspots, which are caused by the Sun's magnetic field becoming more active and complex. This increased magnetic activity leads to more frequent solar flares and other solar events. The relationship between solar maximum and sunspots is direct, as the occurrence of sunspots is one of the most visible indicators of the Sun's activity level. When the solar cycle approaches its maximum phase, scientists often observe a marked rise in sunspot numbers, which correlates with heightened solar activity. At solar maximum, the Sun can produce numerous sunspots, sometimes reaching into the thousands, and these spots can be used to study the Sun's magnetic field and its dynamics. The solar maximum can also have various effects on Earth, including influencing satellite operations, radio communications, and even power grids, due to the increased solar wind and radiation that can occur during these times. Understanding solar maximum and its relationship with sunspots is crucial for both astronomers and those who rely on technology that can be affected by solar activity, helping to predict and mitigate potential impacts on our increasingly technology-independent society. A dwarf planet is quite different from a regular planet, and to understand these differences, we need to explore a few key aspects. First, let's consider what defines a regular planet. According to the International Astronomical Union, a planet must meet 3 criteria. It must orbit the Sun, it must be massive enough for its gravity to shape it into a nearly round form, and it must have cleared its orbit of other debris. This last point is crucial, as it means that a planet has become gravitationally dominant in its vicinity, either by absorbing or ejecting other objects around it. On the other hand, a dwarf planet, while it also orbits the Sun and is large enough to be rounded by its own gravity, does not meet the third criterion. This means that a dwarf planet shares its orbital zone with other objects of similar size. A well-known example of a dwarf planet is Pluto, which was reclassified from being a regular planet in 2006 because it does not clear its orbit of other debris. Additionally, dwarf planets can be found in various regions of the solar system, including the Kuiper Belt, which is a region beyond Neptune filled with many icy bodies and other dwarf planets such as Eris and Haumea. The distinction between dwarf planets and regular planets also plays a role in how we categorize celestial objects, reflecting our understanding of the dynamics and formation of the solar system. In terms of size, dwarf planets can vary, and while they are generally smaller than the 8 recognized planets, they can still be quite large. For instance, Eris is Similar in size to Pluto and Ceres, the only dwarf planet located in the asteroid belt between Mars and Jupiter is significantly smaller than Earth, but still has enough mass to maintain a spherical shape. The classification of these celestial bodies has sparked discussions among astronomers and planetary scientists as they consider how we define planets and what characteristics are essential for that classification. The differences between dwarf planets and regular planets highlight the complexity of our solar system and the ongoing efforts to categorize and understand the vast array of objects within it. Rogue planets, those mysterious celestial bodies that drift through the universe without being tethered to a star, possess some fascinating characteristics that set them apart from their more familiar counterparts. Unlike traditional planets which orbit stars and rely on their gravitational pull for stability, rogue planets wander freely in the cosmic expanse, which raises intriguing questions about their formation, composition, and potential for hosting life. One of the most striking features of rogue planets is their isolation. Without a star to provide light and warmth, they exist in perpetual darkness, making them incredibly challenging to detect. Scientists estimate that there could be billions of these planets roaming the Milky Way alone, and many of them may be similar in size and composition to the planets we know. Moreover, rogue planets can vary significantly in size, with some being as small as Mars, while others can be as massive as Jupiter or even larger. This diversity in size suggests that they may have formed in different ways, possibly through the same processes that create stars, or as a result of being ejected from their original planetary systems due to gravitational interactions. Another interesting aspect is their temperature. Rogue planets can be extremely cold, with surface temperatures plummeting far below freezing, yet some may retain enough heat from their formation or from radioactive decay to allow for potential geological activity. Additionally, researchers have considered the possibility that rogue planets might host subsurface oceans, similar to those theorized to exist on some moons in our solar system, like Europa. If an ocean exists beneath a thick layer of ice, it could create conditions suitable for life, albeit very different from what we typically recognize. The lack of sunlight, however, poses significant challenges for any potential life forms, as they would need to adapt to the dark and frigid environment. Some scientists even speculate that rogue planets could harbor microbial life, thriving in extreme conditions, akin to life found in hydrothermal vents on Earth. Furthermore, the study of rogue planets opens up exciting avenues for understanding planetary systems and the dynamics of the cosmos. By observing the gravitational effects of these planets on nearby stars, astronomers can gain insights into their mass and trajectory, contributing to a broader understanding of how planets can form and evolve, even in isolation. The search for rogue planets continues to advance, with the development of more sensitive telescopes and detection methods, leading to discoveries that may challenge our current understanding of planetary formation and stability. And in summary, rogue planets are defined by their solitary existence, varied sizes, and the potential for unique geological conjunction. An astronomical conjunction is a fascinating event that occurs when two celestial bodies, such as planets, moons, or stars, appear very close to each other in the sky from our viewpoint on Earth. This alignment can create stunning visual displays, often capturing the attention of both astronomers and casual stargazers alike. The conjunction can happen between any two celestial bodies, but it's particularly noteworthy when it involves the planets, as their movements are often more prominent in our night sky. One of the most notable examples of an astronomical conjunction is the Great Conjunction of Jupiter and Saturn, which occurs approximately every 20 years. The last one took place on December 21, 2020, and it was particularly special because the two planets appeared closer together than they had in nearly 400 years. During this event, Jupiter and Saturn were only about 1/10 of a degree apart, making them look like a double planet, which was an incredible sight for anyone with a telescope or even just a pair of binoculars. Another significant instance is the conjunction of Venus and Jupiter, which often draws attention due to the brightness of these two planets. For example, in November 2018, Venus and Jupiter had a beautiful conjunction where they appeared very close together, creating a brilliant sight just after sunset. Additionally, there's the conjunction of the Moon with other celestial bodies, which happens every month. The Moon's proximity to other planets can lead to various interesting visual phenomena, such as the Moon appearing to pass in front of a planet, resulting in an event known as an occultation. For instance, in 2019, the Moon occulted Mars, which provided a wonderful opportunity for observers to see the event where Mars disappeared behind the Moon for a brief period, only to reappear shortly after. Historically, conjunctions have held significant cultural and religious meanings across different civilizations. Ancient astronomers often documented these events, leading to predictions about future conjunctions, which was sometimes interpreted as omens or signs. In modern astronomy, conjunctions continue to be important for research, as they can help scientists study the atmospheres of distant exoplanets when they pass in front of their stars, blocking a small amount of light, which provides data about their composition and distance. If this ongoing study of celestial conjunctions not only enhances our understanding of the universe, but also enriches our appreciation for the scientists. Use a variety of methods to predict rare astronomical events, and this process often involves a combination of advanced technology. One key approach is the use of telescopes, which can observe celestial objects and phenomena over long periods, allowing astronomers to gather data on their movements and behaviors. For example, telescopes like the Hubble Space Telescope and ground-based observatories provide crucial information about the positions of stars, planets, and other astronomical bodies, helping scientists to track potential events like supernovae, asteroid impacts, or the passage of comets. In addition to telescopic observations, scientists employ complex computer models that simulate cosmic events. These models use the laws of physics, including gravitational interactions, to predict how celestial bodies will move over time. By inputting data such as mass, velocity, and distance, astronomers can forecast the likelihood of rare events occurring. These simulations are refined continually as new data comes in, allowing for more precise predictions. Moreover, scientists also study historical records of astronomical events, which can provide insights into patterns and frequencies. By analyzing past occurrences, researchers can identify trends that may help predict future events. This historical approach is particularly useful for understanding phenomena like meteor showers, as they often follow predictable cycles based on the orbits of comets. Another important tool in the prediction of rare astronomical events is the use of gravitational wave detectors. Facilities like LIGO and Virgo have opened a new window into the universe, allowing scientists to detect ripples in space-time caused by catastrophic events, such as the merging of black holes or neutron stars. These detections provide real-time data that can alert astronomers to significant events happening far away, enabling them to direct telescopes to observe the aftermath and gather further information. Collaboration among scientists worldwide also plays a vital role in predicting rare astronomical events. Many researchers share data and findings through networks and databases, like the Minor Planet Center or the International Astronomical Union, which allows for a more comprehensive understanding of celestial phenomena. This teamwork facilitates quicker responses to potential events, as multiple observatories can be coordinated to observe the same phenomenon from different angles, providing a more detailed picture. Finally, advances in artificial intelligence and machine learning are beginning to revolutionize how predictions are made. Algorithms can sift through enormous datasets, identifying potential astronomical events that might be overlooked by human observers. By training these systems with past data, scientists can enhance the Great American Eclipse, which occurred on August 21, 2017, holds a significant place in the history of celestial events, not only because it was a total solar eclipse that crossed the continental United States from coast to coast, but also due to the immense public interest and engagement it generated. This eclipse was unique, as it was the first total solar eclipse to traverse the US from the Pacific to the Atlantic since 1918, making it a rare opportunity for millions of people to experience the awe-inspiring phenomenon of totality, when the moon completely obscures the sun, casting a shadow on the Earth. The path of totality, which extended approximately 70 miles wide, offered a spectacular view to those within the designated area, with viewers experiencing daytime darkness, a drop in temperature, and the appearance of stars and planets in the daytime sky. The event was not only a scientific marvel, but also a cultural phenomenon, as it captured the attention of the nation, with millions taking to the streets, parks, and even rooftops to witness the eclipse. Schools organized field trips, families planned vacations, and even small towns saw an influx of visitors, all eager to see the eclipse. The excitement was palpable as people shared their experiences on social media, creating a sense of community and connection through this shared moment of wonder. Furthermore, the Great American Eclipse had significant implications for scientific research, as it provided an opportunity for scientists to study the sun's corona, the outer atmosphere that is visible only during a total solar eclipse. Researchers set up stations along the path of totality to collect data, enabling them to better understand solar phenomena such as solar flares and coronal mass ejections, which can impact satellite communications and power grids on Earth. The event also encouraged citizen science, with many amateur astronomers and enthusiasts participating in projects that aim to gather observations and data during the eclipse. In addition to its scientific and cultural significance, the eclipse served as a reminder of the wonders of the universe and the importance of astronomy in our lives. It reignited interest in space, prompting discussions about future space exploration and inspiring a new generation of scientists and astronomers. The Great American Eclipse was a moment that transcended boundaries, bringing people together, igniting curiosity, and reminding us of the beauty and mystery of the cosmos. Light pollution, which refers to the excessive or misdirected artificial light produced by urban areas, significantly impacts our ability to observe astronomical events, particularly rare ones, like meteor showers, comets, and even the occasional supernova. When the night sky is filled with artificial light, the faint light from celestial objects becomes obscured, making it difficult, if not impossible, for observers to see them. This is especially true for events that only occur in a limited window of time, where visibility is crucial, and any hindrance can lead to missed opportunities, which can be frustrating for both amateur astronomers and seasoned professionals alike. Additionally, light pollution affects not only the visibility of distant stars and galaxies, but also the observation of more localized phenomena, such as the phases of the moon or the passing of planets across the night sky. In heavily populated areas, the glow from street lights, buildings, and signage creates a bright backdrop that washes out the delicate features of the celestial events, diminishing the contrast needed to appreciate them fully. This is why many astronomers advocate for dark sky sites, which are areas specifically designated to minimize artificial light interference, providing a much clearer view of the cosmos, allowing enthusiasts to witness the beauty and intricacies of the universe. For example, certain meteor showers are best observed during the darkest hours of the night, yet if a location suffers from significant light pollution, the meteors may be less visible, leading observers to miss peak activity times. This not only affects individual observers, but can also skew data collected during these events, as scientists rely on clear skies to gather accurate information on the frequency and characteristics of meteors. Furthermore, the effects of light pollution extend beyond just human observers. It can also disrupt the natural behaviors of animals and ecosystems, which are adapted to the natural cycles of light and dark. Many species rely on the night sky for navigation, hunting, and other behaviors, and the brightening of the night can lead to confusion, which ultimately affects the overall health of various ecosystems. In conclusion, light pollution poses a significant challenge for those wishing to engage with the wonders of the night sky, particularly during rare astronomical events. The struggle to find dark skies in increasingly urbanized environments highlights the importance of community awareness and efforts to reduce light pollution, ensuring that future generations can continue to marvel at the beauty of the universe. In astronomy, a microlensing event occurs when a massive object, such as a star or a planet, passes in front of a more distant light source, like another star or galaxy, and bends the light from that source due to gravitational lensing, which is a phenomenon predicted by Einstein's theory of general relativity. The gravitational field of the foreground object acts like a lens, causing the light from the background object to focus and magnify, resulting in a temporary increase in brightness. This effect can create multiple images of the distant light source, or even produce a characteristic light curve, which show microlensing events are often used by astronomers to detect objects that are otherwise difficult to observe, such as dark matter, exoplanets, and even rogue planets that do not orbit any star. The beauty of microlensing lies in its ability to reveal hidden astronomical phenomena, as it does not require the light source to be particularly bright or nearby. These events can last from a few days to several months. The study of microlensing has led to significant discoveries, including the detection of objects that contribute to the elusive dark matter in the universe. Researchers utilize large telescopes and coordinated observation campaigns to monitor potential microlensing events, allowing them to gather data and analyze the light curves. To learn about the properties of the lensing objects, the gravitational influence of the foreground object can also distort the shape of the background light source, providing valuable information about its nature and structure. Microlensing has opened up new avenues in the search for exoplanets, as planets orbiting stars can also act as gravitational lenses. This method has proven to be a powerful tool in the field of astrophysics, particularly in the study of the distribution of matter in the universe and the search for planetary systems beyond our own. The ongoing development of automated surveys and advanced algorithms continues to improve our ability to detect these fleeting events, enhancing our understanding of the cosmos and the various objects that inhabit it. Solar eclipses, those breathtaking celestial events, have long fascinated both scientists and the general public. But what many might not realize is how these occurrences can influence animal behavior. During a solar eclipse, the moon moves between the Earth and the Sun, casting a shadow that temporarily darkens the sky. This sudden change in light can confuse animals, leading to a variety of intriguing behaviors. For example, birds, which rely heavily on daylight for their activities, often stop chirping and return to their nests, as they interpret the dimming of light as an indication that night is approaching. This behavior can be observed in various species, from sparrows to larger birds of prey, all reacting similarly to the sudden shift in their environment. Similarly, mammals that are typically diurnal may exhibit unusual behaviors during an eclipse. Animals such as squirrels, which are known for their daytime activity, may retreat to their dens, while some species of bats may become active as they mistake the eclipse for the onset of night. This is particularly fascinating, as it demonstrates how deeply ingrained the circadian rhythms of these animals are, and furthermore, livestock like cows and sheep can become unsettled or stressed during an eclipse, often gathering together in confusion, as they too are influenced by the sudden change in their surroundings. In aquatic environments, fish and other marine creatures might also display altered behavior during a solar eclipse. Some researchers have noted that fish tend to swim closer to the surface, possibly due to the decrease in light disrupting their usual patterns. This can create a brief but significant change in the dynamics of underwater ecosystems, as the light levels can influence the feeding patterns of both predators and prey. Interestingly, some studies have suggested that the impact of solar eclipses on animal behavior may extend beyond immediate reactions to changes in light. There is evidence to indicate that animals can experience heightened stress levels during these events, which could have longer-term implications for their health and social structures. This is particularly important for species that are already facing pressures from habitat loss and climate change, as the additional stress of an eclipse could have cascading effects on their populations. Moreover, the cultural significance of solar eclipses cannot be overlooked, as many human societies have historically noted the behavior of animals during these events. In some cultures, the unusual activities of animals during an eclipse were seen as omens or signs, leading to various rituals or beliefs surrounding them. Throughout history, astronomical phenomena have significantly influenced various events, shaping cultures, guiding explorers, and impacting societal beliefs. One notable example is the Great Comet of 1910, which sparked widespread fear and fascination. People believed that the comet's tail, filled with cyanogen gas, could poison the Earth's atmosphere, leading to panic and even the sale of comet pills, which this event highlights how astronomical occurrences can stir public sentiment and fears, often leading to dramatic reactions. Another fascinating instance occurred in 1066, during the time of the Norman conquest of England. The appearance of Halley's Comet was interpreted as an omen, signaling the divine favor of William the Conqueror. The Bayeux Tapestry depicts this comet, framing it as a celestial sign that foreshadowed the Battle of Hastings, which ultimately changed the course of English history. The belief in omens from the heavens was prevalent, and such interpretations often guided the actions of leaders and the public alike. Additionally, the alignment of the planets has played a role in cultural and religious events. For instance, in 300 AD, a solar eclipse coincided with the reign of the Roman Emperor Constantine. This celestial event was seen as a divine sign, leading to the Edict of Milan in 313 AD, which granted religious tolerance throughout the empire. Such astronomical occurrences have often been woven into the fabric of political power and religious transformations. In ancient times, the Mayans were known for their advanced understanding of astronomy, which influenced their agricultural practices and religious ceremonies. They meticulously tracked celestial events, such as the movements of Venus, which they believed were tied to warfare and other significant events. Their calendar was intricately linked to the cycles of the moon, sun, and planets, illustrating how astronomy shaped their society and daily life. Similarly, the supernova SN 1054, which was observed in 1054 AD, created the Crab Nebula, and its light was visible during the daytime for weeks. This event was recorded by various cultures, including the Chinese, who referred to it as a guest star. Its visibility influenced cultural narratives and interpretations of the cosmos, leading to various myths and stories that were shared among people of different backgrounds. The influence of astronomical phenomena wasn't limited to ancient civilizations. In 1846, the discovery of the planet Neptune was a significant event that was based on mathematical predictions regarding its existence. This event not only expanded our understanding of the planets around the galaxies, play a crucial role in observing rare astronomical events, serving as our primary tool to explore the vastness of the universe and allowing us to witness phenomena that are on Earth. When a rare event, such as a supernova, comet, or eclipse, occurs, telescopes enable astronomers and enthusiasts alike to capture these fleeting moments, providing a window into the workings of the cosmos. The power of telescopes lies in their ability to collect and magnify light, making distant objects visible and revealing details that are otherwise impossible to see with the naked eye. So, for instance, during a supernova, which is the explosive death of a star, telescopes can detect the light emitted from the explosion, helping scientists study the chemical makeup of the star, the mechanics of the explosion, and even the impact on surrounding celestial bodies. Different types of telescopes, such as optical, radio, and space telescopes, optical telescopes, which use lenses or mirrors to gather visible light, are particularly effective during events like solar or lunar eclipses, where they can provide stunning images and detailed observations of the phenomenon. On the other hand, radio telescopes can detect radio waves emitted by astronomical objects, enabling scientists to observe events like pulsars or the remnants of supernovae, which may not be visible in other wavelengths. Moreover, space telescopes, like the Hubble Space Telescope, have the advantage of being above Earth's atmosphere, which allows them to take clearer images without atmospheric distortion. This capability is especially important for observing rare events that might only happen once in a lifetime, or even once in human history, such as the transit of Venus or the discovery of new exoplanets. These telescopes can provide crucial data, capturing images and spectra that help astronomers understand the nature of the events, the distances involved, and the physical processes at play. Telescopes also facilitate collaboration among scientists around the world. When a rare astronomical event is predicted or detected, observatories can network, sharing data and observations in real time. This collective effort enhances the understanding of the event, as different telescopes might capture varying aspects of it, contributing to a more comprehensive picture. For example, during the detection of gravitational waves from a neutron star merger, telescopes around the globe turn their attention to the source, observing the event in multiple wavelengths, from gamma rays to infrared, thereby enriching the scientific analysis. Climate change, a pressing global issue, can have unexpected implications for the observation of celestial events, affecting both amateur and professional astronomers alike. The most noticeable impact comes from the alteration of weather patterns, which can lead to an increase in cloud cover, precipitation, and atmospheric turbulence. These changes make it more difficult to observe celestial phenomena, such as meteor showers, eclipses, and planetary alignments. For instance, in regions where clear skies were once common, increased humidity and cloud formations can obscure visibility, leaving stargazers frustrated and deprived of the spectacular sights above. Moreover, rising temperatures can also influence the air quality, leading to more atmospheric pollution, which scatters light and diminishes the clarity of the night sky. This is particularly evident in urban areas, where light pollution has already made it challenging to see faint celestial objects, and climate change could exacerbate this issue. The increased presence of particulates in the atmosphere, due to industrial activities and wildfires, can further degrade the quality of astronomical observations, making it even more difficult to spot stars and distant galaxies. Additionally, climate change can affect the timing of celestial events. For example, certain meteor showers are influenced by the Earth's atmospheric conditions. Changes in wind patterns. Temperatures might alter the way meteors enter the atmosphere, potentially impacting their visibility or frequency. It's also worth considering that changing climate patterns can shift the habits of wildlife, which can affect the experience of observing celestial events in natural settings, as animals might be more active or behave differently due to altered seasonal patterns. Furthermore, the scientific community relies on long-term data for tracking celestial events and understanding their cycles. Climate change can disrupt the consistency of environmental conditions, which is crucial for astronomers who depend on reliable weather patterns to plan their observations. This inconsistency can complicate research efforts, making it harder to gather accurate data over time. And lastly, as climate change leads to more extreme weather events, such as storms and hurricanes, these phenomena can pose direct threats to observatories and telescopes, particularly in vulnerable locations. Damage to equipment or even complete destruction of observatories could hinder scientific progress and the ability to study astronomical events in detail. As we witness the ongoing changes in our environment, it is essential to understand how climate change not only affects life on Earth, but also our connection to the cosmos, reminding us that our planet's health is intricately linked to the wonders of the universe we seek to explore. The Kuiper Belt, a vast region of icy bodies that lies beyond the orbit of Neptune, plays a crucial role in our understanding of comets, as it is considered the source of many short-haired comets that visit the inner solar system. This area, which is home to thousands of small icy objects, acts as a reservoir of primordial materials from the early solar system, containing remnants from its formation about 4.6 billion years ago, when these icy bodies, known as Kuiper Belt objects or KBOs, are perturbed by gravitational interactions. Often from larger planets like Neptune, they can be nudged inward toward the Sun. As they approach the warmer regions of the inner solar system, the heat causes the ices within these objects to sublimate, creating the bright comas and tails that we associate with comets. The significance of the Kuiper Belt extends beyond merely being a birthplace for comets. It provides valuable insights into the composition of the early solar system. By studying the properties and behaviors of comets that originate from this region, scientists can infer the types of materials that were present during the solar system's formation. This includes understanding the distribution of water, organic compounds, and other essential elements that may have been crucial for the development of life on Earth. It distinguishes the word abelu to be home to many objects that have remained relatively unchanged since the solar system's infancy, offering a glimpse into the conditions and processes that prevailed during that time. Moreover, the Kuiper Belt's dynamic environment is also a topic of interest for astronomers, as the interactions among its icy bodies can lead to the creation of new comets, or even the ejection of some objects into the interstellar space. This ongoing activity contributes to the ever-changing nature of the belt, making it a fascinating subject for ongoing research. As new missions, like NASA's New Horizons, continue to explore this distant region, our understanding of its significance in relation to comets and the broader narrative of our solar system's history becomes clearer. The Kuiper Belt, therefore, is not just a distant frontier, but a vital piece of the puzzle in unraveling the mysteries of our cosmic neighborhood. Amateur astronomers can engage in observing rare astronomical events in a variety of exciting and meaningful ways, creating an opportunity for them to contribute to the field of astronomy while enjoying the wonders of the universe. One of the most accessible methods is through local astronomy clubs or societies, which often organize star parties, wherein these gatherings can be a fantastic way for amateurs to learn from more experienced astronomers, as well as to meet others who share their passion for the night sky. Moreover, many astronomical organizations, such as the American Astronomical Society, provide resources and information about upcoming events, like meteor showers, eclipses, or transits of planets across the sun, allowing amateurs to prepare in advance. Participating in citizen science projects is another excellent way for amateur astronomers to get involved. Platforms like Zooniverse allow individuals to analyze data from telescopes around the world, helping scientists track phenomena such as supernovae and variable stars. This not only enhances the understanding of these rare events, but also contributes to real scientific research. In addition, using social media and online forums can keep amateur astronomers updated and connected with others interested in the same events. There are many websites and apps dedicated to astronomy that provide alerts and notifications about rare occurrences, helping enthusiasts to plan their observations. For instance, apps can let users know when a comet will be visible or when to expect a peak in a meteor shower, making it easier for them to grab their telescopes and head outside at the right time. Another exciting way to participate is through astrophotography, where amateur astronomers capture stunning images of celestial events such as eclipses or planetary alignments. With modern cameras and telescopes, even beginners can achieve remarkable results, and sharing these images online can inspire others and contribute to a community of learning. For those who are more adventurous, traveling to locations known for their clear skies or unique vantage points can enhance the experience of observing rare events. Places like national parks or high-altitude areas often provide an unobstructed view of the night sky, making them ideal for witnessing events such as lunar eclipses or the northern lights. Finally, engaging in educational outreach by sharing experiences and knowledge with schools or community groups can foster a greater appreciation for astronomy and inspire the next generation of stargazers. Whether through organizing viewing events or giving presentations about upcoming astronomical phenomena, amateur astronomers can play a vital role in spreading excitement. Space agencies play a crucial role in tracking and predicting astronomical events, acting as the primary organizations responsible for observing celestial phenomena, gathering data, and disseminating important information to the public and the scientific community. Agencies such as NASA, ESA, and others utilize a variety of sophisticated instruments, including telescopes, satellites, and ground-based observatories, to monitor the movements of asteroids, comets, and other objects in space. By employing advanced technology, they can detect these objects long before they reach Earth, allowing for early warning systems to be put in place, which is essential for planetary defense against potential collisions. In addition to observing near-Earth objects, space agencies also study more distant astronomical events, such as supernovae, gamma-ray bursts, and the behavior of black holes. This involves collaborating with international observatories, sharing data, and conducting joint missions, which enhances the understanding of the universe and the intricate dynamics at play. For instance, missions like the Hubble Space Telescope, which has provided stunning images and invaluable data about distant galaxies, have contributed significantly to our knowledge of cosmic events and the evolution of celestial bodies. Moreover, space agencies are involved in predicting events such as solar flares and coronal mass ejections, which originate from the Sun and can have profound effects on Earth's magnetosphere. By monitoring solar activity, agencies can issue alerts that help protect satellites, power grids, and communication systems from potential disruptions caused by these solar events. The prediction of such phenomena is vital for maintaining the integrity of technology that society relies on every day. Furthermore, the role of space agencies extends to public education and engagement. They often organize events, workshops, and outreach programs to inform the general public about upcoming astronomical events, such as meteor showers, eclipses, and planetary alignments. This not only fosters a greater appreciation of astronomy, but also encourages interest in science, technology, engineering, and mathematics, STEM, fields among younger generations. As technology advances, the capabilities of space agencies in tracking and predicting astronomical events continue to improve, leading to more precise models and a better understanding of cosmic processes. So, for example, the use of artificial intelligence and machine learning in data analysis allows scientists to sift through vast amounts of information more efficiently, identifying patterns and making predictions that were once impossible. This innovation opens up new avenues for research and enhances the ability to respond to potential threats from space. In summary, The role of space agencies in tracking and predicting astronomical events is multifaceted, encompassing scientific integrations on Earth, while not a daily concern for most people, pose significant dangers that can have catastrophic consequences. First, it's important to understand the sheer size and speed of asteroids, which can vary greatly from small rocks to larger bodies, some measuring hundreds of kilometers in diameter. When an asteroid enters the Earth's atmosphere, it travels at incredibly high speeds, often exceeding 20,000 miles per hour. And the friction with the atmosphere can cause it to explode before it even reaches the surface, creating what we call an airburst. This explosion can release energy equivalent to thousands of atomic bombs, capable of flattening entire cities, causing widespread destruction and igniting fires across vast areas. Moreover, if a larger asteroid makes it to the surface, the impact can create massive craters, displacing vast amounts of earth and rock, and sending debris flying into the atmosphere. This debris can block sunlight for an extended period, leading to a nuclear winter scenario, where temperatures drop significantly, disrupting ecosystems and agriculture. Such climatic changes can trigger food shortages, leading to famine and widespread societal upheaval. The potential for tsunamis is another serious concern. If an asteroid strikes an ocean, the force of the impact can displace enormous volumes of water, generating massive waves that can devastate coastal regions. The historical record has shown that significant asteroid impacts have occurred in Earth's past, such as the one believed to have contributed to the extinction of the dinosaurs approximately 66 million years ago, leaving a lasting mark on the planet and its biosphere. Additionally, there are long-term effects to consider. Dust and soot from an impact can linger in the atmosphere for years, affecting climate and weather patterns globally. The extinction of various species as a result of such impacts showcases the interconnectedness of life on Earth and how the repercussions of an asteroid impact can ripple through the entire biosphere. The psychological and economic impacts also cannot be overlooked. The fear of an impending asteroid impact can lead to anxiety and stress, while the actual aftermath of a significant impact would require enormous resources for recovery and rebuilding, straining economies and infrastructure. Scientists and researchers are continuously monitoring near-Earth objects to mitigate the risk of potential asteroid impacts. Various space agencies have developed strategies for detecting and tracking these celestial bodies, and some are even exploring the possibility of deflecting asteroids that pose a threat to Earth. By understanding the dangers of asteroid impacts, society can better prepare and protect itself. Cultural interpretations of eclipses vary greatly across different societies, reflecting the unique beliefs, histories, and values of each culture. In ancient China, for example, eclipses were seen as a sign of discontent among the heavens, often interpreted as a warning, particularly for the emperor, who was thought to be the link between heaven and earth. The Chinese would sometimes perform elaborate rituals to appease the celestial forces, believing that the emperor's fate was tied to these cosmic events. In contrast, the ancient Greeks viewed eclipses more scientifically, with philosophers like Aristotle and later Ptolemy. They recognized that eclipses occurred due to the alignment of the Earth, Moon, and Sun, marking a shift towards a more rational understanding of celestial events. Moving to the Americas, the Mayans had a deeply intricate relationship with eclipses. They meticulously recorded solar and lunar eclipses in their calendars. Eclipses were often seen as moments of transformation, signaling changes that could affect their agricultural cycles or the outcomes of battles. Similarly, the Aztecs believed that solar eclipses were a manifestation of the sun being devoured by a powerful creature, leading to rituals that aimed to protect the sun and ensure its return. This idea of the sun being threatened speaks to the importance of agriculture and sustenance in these civilizations, highlighting how eclipses were tied to their survival. In parts of Africa, various tribes have their own interpretations of eclipses. For some, they are seen as a time of reflection, a moment to consider one's life and community. In Nigeria, for example, some cultures believe that an eclipse may indicate the anger of the gods, prompting community gatherings and prayers for forgiveness or protection. Conversely, in other regions, eclipses might be viewed as auspicious events, heralding good fortune and opportunities for new beginnings. This diversity of beliefs demonstrates how the same astronomical phenomenon can inspire vastly different responses depending on cultural context. In India, eclipses are often surrounded by religious significance. Many Hindus believe that during an eclipse, the sun and moon are temporarily overshadowed by Rahu, a legendary figure associated with chaos and confusion. As a result, it is common for people to engage in purification rituals before, during, and after an eclipse, such as taking holy baths or chanting mantras. This period is viewed as an opportunity for spiritual cleansing, with some